Start recording. All right, so we're gonna talk about. I gotta get my. I guess I don't have to. All right, so it should be sharing here in a second. All right, so we're gonna talk about the story problems here. In Notability. Okay, so so first of all, Claire, did you read and did you understand what the question's trying to get at here in 23?
Kind of.
I wanted to make it so that your phone was kind of like a map, right? So when you look at a map, the distance between places, it never changes, you know, like on a map, nothing is going to move around on the page. But so they're all the same distance apart, but it's a much smaller distance than actual distance. So that's kind of what I wanted to, you know, you're kind of using your phone as a map where the picture of your path never changes. All right, so basically we have two things going on at the same time here. We have how long the path to your destination looks on your phone screen, and we have the actual distance between you and your destination, right? So so the first thing I got you started off with part A is the first thing you have to decide how you're going to set up your ratio. So you can put actual distance on top and you can put the distance on your phone screen on bottom and it'll still work out the same. But you just have to, it's always a good idea, let me get my laser pointer out. It's always a good idea to write this down in words first. So figure out what the story problem's about, write it down in words, and then you know where to put the information from the problem. So like if it's a distance on your phone screen, you know it goes on top of the fraction. If it's an actual distance, you know it goes on bottom. So so once we have that determined, then we are going to we're going to use the ratio that they gave us in the problem. So you choose to lock your map at a scale of 1 inch to 4 miles, and that means like if a path is 1 inch on your phone screen, then it's actually 4 miles away from you in real life. Got that?
Yeah.
So so we put the ratio that they give us here. Okay, we know that 1 inch on our phone screen means 4 miles. That fraction has to be equal to the information that we have in the problem. So we're testing this out by putting in your grandparents' address as a destination, because you already know they live 14 miles away from you. So since that's an actual distance and it's given to us in the problem, we want to put it on the bottom because we said we're going to put the actual distances on the bottom of all our fractions. All right, so if that's what we have, then there's only one thing left to figure out. We have 3 of the 4 pieces for the proportion. The 4th is always the unknown, the variable. So so now we're ready to solve it. So how would you solve this?
You would do 1 times 14 and then 4 times x.
Perfect. All right, so let's do that. I'll just keep going using red. Why not? Okay. So yeah, those are our cross products. So 1 times 14. You don't have to write it like this. You can just write 14 if you want to do the math there. But ultimately, yeah, this is what we get. Okay. So now it's a really easy equation to solve. All we have to do is divide by 4, and we get 3.5 equals x. Okay. So now finish it for me, Claire. What would be a good way to answer this problem?
The path on the phone screen is 3.5 miles.
Does that make sense? Is
inches?
Your phone, yeah, inches, right? And that's great. That's what I always tell my students is like, you have to think about it logically. Is your phone 3.5 miles wide? No. So it's probably the other label, but that's good. That's a good way to think that through. So yeah, a good answer is the path is 3.5 inches on your phone screen. Okay. Okay, so in part B, I flipped the script on you. And now you are driving, okay, so you're out volunteering to pick up dinner for your family. Because you're a mercy girl, you hop in the car, buckle your seatbelt, and place the phone in the dashboard cradle so you can safely drive and see your ride to the restaurant. Obviously, we're all going to do that. Okay, felt it necessary to put that in there. On your screen, you estimate the path to Royals to be about 1.75 inches long. How far away are you? So now what did I give you in this problem? What information do you have? Do you have the phone screen distance or the actual distance?
The phone screen difference.
Yeah, we have the phone screen distance, right. So that means the question, now remember, the question is so important because that tells us what our variable is going to be. This is what we're trying to find. How far away are you from Royals? We're talking real life here. So the actual distance, we're still using the same ratio, and that's kind of nice. So we're still using 1 inch equals 4 miles. But now we know that the phone screen distance is 1.75, so that goes on top, and we're looking for the actual distance. So now our x is on the bottom, but the great thing about cross products is it makes it so easy to solve. All we have to do is multiply these, set them equal. Okay, so we get 1x equals 4 times, that's not times, 4 times 1.75, and that doesn't get much easier. We just have to do some multiplication there, and you'll see that the answer is 7. All right, so what label goes on our answer this time?
It's 7 miles to Royals.
Perfect. 7 miles to, you are 7 miles away. Have you ever had Royals?
Mm-mm.
Oh, so good. If you like
I've
spicy.
never had McDonald's either.
Well, you're not really missing anything there, but if you like spicy chicken, that's good fried chicken there. It's a great place to go. Maybe if they see this on my video, they'll give me some free chicken. Who knows? Like anybody's watching it. Okay. So yeah, you are 7 miles. I never finished my thought, but you are 7 miles away. That would be a great way to answer that problem. Okay. So this one, did you watch the video that I posted, the video lesson?
Yeah.
Okay, I had a student. So you got the answer to this one?
Mm-hmm.
Okay, good. So we can skip that one. Let's just talk about 25, and then you'll be sure that you know how to do these. All right, and this, I'm sure this will help everybody else when I post this video. So it's a good thing that we're going through it. Okay, your brother, who's stationed overseas, is finally out of quarantine and is heading home. He's driving from Fort Jackson in Columbia, South Carolina to Louisville, and he's already on his way. He calls you from Asheville, North Carolina, and says that he's completed about 30% of his trip, and that took him 2.4 hours. Okay, so how long is the total trip from Fort Jackson to Louisville? Okay, so the first thing you need to realize about this one, I'm going to do some highlighting here, is that it is a percent problem. We know that because we've been given a percent. The other way we would know that is the question will ask us, like, what percent, blah, 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 blah. But it's going to be in there somewhere. So we know it's a percent problem. The first thing you should think when you think percent problem is go back to this template that we've been using. The percent over 100 is equal to, and with story problems especially, I like to write it this way, not is and of, because is and of is just like a shortcut. It doesn't, it doesn't make any sense to us. But the part and the whole, that makes sense. Like, so he's done part of his journey, right? Okay, so this is the part, and they're asking for how long is the total trip. So basically find the whole thing. That's what they're telling us to do. All right, so they gave us the part, they gave us a percentage, so we can plug those in, and then we're looking for the whole thing, so that's where we put our variable. All right, so let's fill that in. It's going to be 30 over 100, 30% over 100%, and then 2.4 over x. Okay, and I didn't do this. I should have done this. I should do it on every problem, but we define our variables. X is time of total trip. Okay, so it's not the distance. When we get our answer, we're not going to put miles because our label here is hours. So it is actually not the length of the total trip. That question is a little misleading. So we got to be thinking logically here. Okay, but the solving part is easy. Hopefully you feel really good about that. Cross products. Yeah, good. Okay, so We get 30x. You've been a great equation solver, and your work has been really neat. So keep it up. Okay. Now I did that math in my head. Multiplying by 100 is really easy because you can just move the decimal 2 spaces to the right. All right. So 2.4 becomes 240, and then all we have to do is divide by 30, and we get x equals. So we can cross off these zeros, and 24 divided by 3 is 8. All right. Now you want to ask yourself with every story problem, does this answer make sense? Does it seem like if 30% of his trip was 2.5 hours roughly, does it seem like the whole thing would be about 8 hours?
Yeah.
Yeah, that makes sense, right? We're expecting it to be 30% is less than half. So we expect our answer to be more than double whatever 2.4 is. So we expect it to be more than 5. But if you get something crazy like 80, then you should also know that that's a mistake, right? It's not going to take him 80 hours if 30% of it was only 2.4. So maybe you just, when you use the calculator, you left off a 0 or something. So you want to check and make sure your answer makes logical sense before you commit to it. So the trip will take about 8 hours. And remember, you can say about, you don't have to, but we're estimating here because he estimated that it was about 30% of his trip. So it is an estimation. Okay. The cool thing is I looked this problem up. I looked up Fort Jackson to just I wanted to find a naval base that was on the East Coast. And I made the answer so that it would be 8 hours, but then I looked up how far it actually was away, and it said 7 hours and 55 minutes. So it's pretty crazy. It's actually accurate. All right. So how do you feel about those? Feel like you could do one of those on a test?
Yeah.
Okay. Well, good, because they'll be easier than these, or they'll be as difficult, but they're not going to be any harder.
Mm-hmm.
Okay. Anything else?
I don't think so.
Okay, cool. Well, I'm glad you came to the Zoom session because now your classmates benefit from getting to see some of those story problems done. So thanks for coming. Good luck. Get it turned in as quick as you can. And if you want to see the answer key once you've turned it in, just let me know and I'll email it to you.
Okay.
All right.
Thank you.
No problem. See you later.
Yeah.